21 August 1993, a tragic event occurred. Communications with the Mars Observer spacecraft were lost during a sequence referred to as the pressurization sequence. This was a sequence in preparation for insertion to orbit about Mars.
Once again, I mean, we're always trying things because they're hard, not because they're easy. And so once in a while, we're going to have a failure because we are trying hard things.
But I had been fully anticipated that we could have problems with this instrument. This was a new ball game completely, okay? But I was not concerned about the spacecraft. It never crossed my mind that spacecraft would let us down. And so this was a blow in the sense of, wow, something I completely didn't expect.
You know, we held out hope for a while that maybe it would come back, maybe they'd find it or recover it or something, and then eventually that settles down and you realize the mission was lost.
I was devastated. I think we all were, and it really wasn't clear at the time whether we were going to have a follow-on to actually do what that mission was supposed to do.
So that was extremely hard to take. What made it easier is the amount of time we had for grieving was actually pretty short.
NASA decided that we want to continue this and go back to Mars. And so we had to snap out of it, literally, and get back to thinking about and fighting for the next mission, which is Mars Global Surveyor. It was a difficult time, and it was the first time I think I really felt I had to get in there and argue with my colleagues, but as the PI, it was particularly for me, that we needed to get back to Mars and we needed to get back with this instrument. Knowing that they couldn't carry all 6 or 7 instruments, only 4 would go, the laser altimeter had to be one of them, okay? The engineers had a chance to kind of just not change it, but do some things a little bit better.
That's what engineers like to do, is they fix all their first round mistakes in the second round and make new ones.
We were asked immediately, how long will it take you to rebuild another copy of MOLA? How much is it going to cost? Can you get your team back together in time? Do you have the parts? So there was immediately a flood of things we had to do.
Geometry brought me in for the detector engineer who just left the Goddard at the time. So I was lucky to join the team working on the detectors. We were only given, I think it's 3 years to rebuild it. It's shorter than usual.
And everyone, all the management knew that means there's no wiggle room really in your schedule.
But the team was largely still there, and everyone is geared up to redo it since the first one didn't make it. So everyone really wanted to do it again and do it right.
While the Goddard team was building MOLA 2 for the Mars Global Surveyor mission, a small team seized a long-awaited opportunity to hitch a ride on the Space Shuttle with an experiment known as the Shuttle Laser Altimeter.
I think confidence comes from demonstration. Sometimes you have to do more, sometimes you have to do less.
Working personally to build that instrument, we built it at Goddard in our lab down the hall without any fancy paperwork or flight procedures or anything. We just built it.
I was hired then to come on board working on the shuttle laser altimeter, and I was brought in specifically to work on precise positioning, precise pointing, and precise geolocation of the surface footprints.
And we tested it on the roof, shined it over to a bank building 11 kilometers away, lined it up, and it was ready for the shuttle.
It was a hitchhiker special that we flew with help from NASA headquarters on the Space Shuttle Endeavour.
Booster ignition and liftoff of Endeavour in pursuit of a Japanese satellite.
Throttle down as the orbiter prepares to pass through the area of maximum dynamic.
They turned it on for us, and the first time they turned it on, the shuttle's upside down with the laser pointing at Earth. We're over the middle Pacific.
First light showed all this fuzz over the surface of the Earth. We're all looking. We thought we got something wrong. We realized later we were seeing the boundary layer clouds over the ocean. When we came over land, the fuzz was the height of the trees.
All of a sudden, the laser pulses got shorter and shorter distances.
The first landfall of the shuttle laser altimeter in the first orbit went right over the summit of the Mauna Kea volcano in Hawaii. Well, we're extraordinarily delighted to report that the shuttle laser altimeter experiment, it's a hitchhiker experiment on STS-72, has performed absolutely nominally. In fact, everything has worked even beyond our expectation.
And that was a genuine first light experience with MOLA technology, but on Earth.
Really had to get those data sets out there, and you had to get a couple people that really bought into it and built on it and convince others that this worked.
As the data from the shuttle laser altimeter began to convince some skeptics, the Goddard team finished the MOLA instrument again.
Our MOLA team really came through. It was just really another great experience for many of us, including me. We were able to deliver to the Mars Global Surveyor project, and it got launched.
And we have liftoff of NASA's Mars Global Surveyor as America begins its journey back to the red planet.
6 solids. And when Mars Global Surveyor started getting closer to Mars, we were going to go into this aerobraking phase. That was an opportunity that we had to go ahead and turn on the lasers and see if we could track the surface.
Somebody been carrying it before. And Station 45 was having problems locking up to the 2K data.
What was that? You said 1607 or 16?
Can you tell if MOLA has been turned off?
Copy up, Mike. Kill my query and restarted as soon as that query is up.
Is that the nadir event? That must be the nadir event.
I'm hungry. You didn't really want those sandwiches.
Look at the laser coming back, Rob.
Rick says about 18.
It's going to be too fast and I got too much data.
Look at that. Yes.
Look, there's a little tiny terrace. This is the first profile of a crater we've ever seen on the planet.
That is.
Rob, nice laser.
Oh, there.
Right. We have Mars, finally. 12 years. All right, let's take a look. I don't understand.
Over a decade later, the Goddard team had proof. Planet-scale laser altimetry worked. It could map distant craters and valleys and mountains. It changed the game.
Today, we've ushered in a new era in the remote sensing of Mars.
And this particular data set that we've acquired has in fact enabled us to generate what we consider a very detailed description of the shape of the planet Mars.
This has significant implications for the flow of water early on Mars.
We believe this is one of the youngest features on the planet. We're seeing a planet that is very different from Earth. And it's telling us something about the Earth in an indirect way that says that not everything works in the way that we originally had in mind.
The kind of measurements that we're making now are allowing us to, characterize Mars on timescales of days to years now. And then the next step is to try to go back eons and try to figure out what changed on Mars.
I mean, at that time, we used to brag that Mars was mapped better than the Earth. The accuracy of MOLA was so good, and after a couple of years, the coverage was so good. It was definitely a more accurate map of a planet than any planet.
And this came out of it can't be done in the mid-'80s to a tool that we now accept as the standard.
For those of us that worked on MOLA, it was transformative. It wasn't at a destination or a place that we were as much as a place that we would become.
In some ways, we were in demand to consider whether we could provide a laser altimeter to another mission.
Things were not working the way we expected them to, and there were mysteries, and we weren't expecting, after MOLA in particular, to have mysteries at that point.